Alright, so today we're going over 3.4 slopes and forms of linear equations. So we're going to talk about the slope of a line, the slope-intercept form of a line, and the point-slope form of a line. Alright, so the definition of slope. The slope of a line is the numerical value for steepness. So for example, if we draw a little picture over here, we have 2 points. Let's say this is P1. It's going to have x1, y1 as its coordinates. And we're going to have a line. This is going to be another point on the line, P2, which is x2, y2. And so basically, I want to figure out how steep this line is. So basically, I'm going to find how far it runs over how far it rises. The slope can be calculated as follows. The slope equals m, which is pretty much the universal number we use for slope in algebra, is rise over run. So my differences in my y's over the differences in my x's. And once again, the letter m is the standard notation for the slope of a line. So we're going to see how far it rises. So as we move left to right, the possibility for a line slope is going to be positive as it rises from left to right. In other words, it's like going uphill, right, as we move left to right. And the slope with negative slope, or line with negative slope, falls as we move left to right. So as we move to the right, it'll go down. So next, this first exercise says compute the slope of the line passing through these 2 points, and it gives us the point 2, 3, and 4, negative 12. So in doing this, first thing you want to do is label your points. It's always helpful, keeps track of things. And then write your formula down. So it's going to be changing y's, y2 minus y1 over x2 minus x1. And it really doesn't matter which point is first, as long as you keep the y's over the respective x's, you should be fine. So in this case, I said I'm going to take negative 12 minus 3 all over 4 minus 2. So that's going to give me negative 15 over 2. And that's my slope. And you always want to reduce your fractions if possible. This doesn't reduce, so it's just negative 15. So for every 2 units it moves to the right, it's going to go down 15 units. So we had a line we were graphing. If we had a point, we could go 2 units over, 15 units down, we get a next point on our line. Horizontal and vertical lines. For a horizontal line of the form y equals b, the slope is 0, because basically there is no rise. If all your y values are the same, you're basically going to have something like b minus b over your x2 minus x1, and that's going to give you 0 over whatever your run is. And so that's going to be 0 slope. For a vertical line of the form x equals a, the slope is undefined, because basically you're going to get your y2 and your y1, subtract them from each other, but here in the denominator you're going to get a minus a, which basically has division by 0. So your rise over 0 run is undefined. It's not 0. Slope-intercept form of a line is y equals mx plus b. The slope-intercept form of a line, once again, is y equals mx plus b. M is the slope, and 0b is y-intercept, because we can see if we plug in 0 for x, right, we'll just get y equals b back out. All right? And if it's 0 for x, that means we have a y-intercept. It says determine the equation of the slope of the line. Determine the slope of the line defined by the equation for exercise 2. And we have 4x plus y all over 3 minus 8 equals 11. So first thing I want to do is add 8 to both sides. So I'm going to get 4x plus y equal all over 3 equals 19. And the reason why I want to do this is that I want to get it into slope-intercept form of a line, because the reason why is the slope is the coefficient in front of x. Right now the coefficient in front of x isn't the slope because it's not in that form. So I'm going to multiply both sides by 3. Get rid of that 3 in the denominator. So this is going to make it 4x plus y equals, and this is going to be 3 times 19. That's going to be 757, I think. 57. And then now that I have it in standard form, I've got my x and my y, I can say, you know, my x and my y, it's in standard form, it's not in slope form, so this is standard. I want slope-intercept form, so I need to move that x to the other side. So I get y equals negative 4x plus 57. And right here, if there was a coefficient in front of y, something other than 1, I divide through it and get the actual slope. But here, since the leading coefficient 1, the slope, this is now in slope-intercept form. So this is going to give me that my slope is now negative 4, which is actually, it's actually for every 4 units I go down, or I run 1 unit for every 4 units I go down, but the 1 is understood. So we just write it as negative 4. But when applying this slope, we go over 1 and down 4. Is that a graph? Nope. Use the slope-intercept form of a line to graph. So once it's graphed this equation using the slope-intercept form of a line, and we have 4x minus 5y equals negative 7y minus 2x plus 6. So I want to get my y's all on one side, so I'm going to add 7y to both sides. I also want to get all my x's on the other side, so I'm going to move all my x's to the right hand side, so I'm going to minus 4x from both sides. And so that gives us what? 2y equals, my y's cancel here, my x's cancel there, minus 6x plus 6. And then I'm going to divide everything by 2. And I divide each thing by 2, not the whole thing by 2, because I want the individual numbers. I don't want to get the whole thing over 2. So I want to get the individual coefficient. Oops. Saying 2, I wrote it down. That's going to give us y equals negative 3x plus 3. So my m is equal to negative 3. And so it wants us to use the slope form of the line to graph. So in other words, I'm going to draw my x and y, and since my slope is negative 3, I know I'm going to have to go down, and my y-intercept is positive 3. So I'm going to have my y-intercept, which is going to be 0, 3. So in other words, I'm going to go up 3, 1, 2, 3. And then to get my next point, I'm going to do what? I'm going to go over 1, and then I'm going to go down 3 units. Right. So it's over 1, down 3, because I have negative slope. Now this just happens to give me the x-intercept. It just happens to do that, but it's not always going to do that. This line just works out like that. So that's how we use that graphing the line with the slope and the y-intercept. Remember, it's understood to be over 1, so we always have to run, for those integer slopes, we always have to run 1 to the right and then up or down depending on the numerator. Point slope form of a line is the following: y minus y sub 1 equals m times x minus x sub 1. M is the slope, x1 and y1 are the coordinates for specific points, x1, y1 on the line, and x and y stand for any point xy on the line. Basically, we've seen point slope form of a line. We just saw it. It's actually the slope formula, which is just going to be y minus y1 over x minus x1. And so basically you just multiply both sides by x minus x1, where y1 or y2 is equal to y, and x2 is equal to x. So we just changed out the y2 and x2 and just made those variables, and then we moved that denominator to the other side. So if you can't think of it, you don't have it written down, or you don't have it written down on your scratch work, you can always derive it from the slope formula. It says write the equation. My page is crooked. Write the equation in slope-intercept form of the line with a slope of 2 and passing through the point 10, -9. So if it has a slope of 2, m is equal to 2, it doesn't give us the y-intercept, so we can't just do slope-intercept form. And it says it wants it in slope-intercept form. Always remember what form they want it in, because they could ask for standard form. They could say leave it in point slope form, things of that nature. So this is going to be my x1, my y1, thank you. And I'm going to just write my equation back out. So I have y minus y1 equals m times x minus x1. And so I'm just going to substitute my numbers in. So I'm going to have y minus a -9 equals 2 times x minus 10. So now I'm going to have y plus 9 equals 2x minus 20. And I'm going to subtract 9 from both sides. I have y equals 2x minus 29. And that's the equation for the slope intercept form. Because I have my basically mx plus, or b being -29. Alright. Next, now notice it says write the equation in standard form of the line passing through the points 6, -9, and -6, -5. So we have to do 2 steps. So the first step is going to be find slope. And then the second step is find equation of a line. And in this case, standard form. So I'm going to have to label this, let's say x1, y1, x2, y2. Just read that. It's going to be m equals, so it's going to be -5 minus a -9, which would be +9, all over -6 minus 6. So that's going to give me what? That's going to give me +4 over -12, which will give us -1/3, because I divided 4 out from the top and bottom. Now that I have my slope, I'm going to say, well, now I'm going to use my second part where I'm going to put it in point slope form. So I'm going to need y minus y1 equals m times x minus x1. Now here's the thing. When you're looking at this, you can pick either point to do this with. It should work with both points. So some people like to pick the points with the smaller numbers. Some people like to pick the points with the least amount of negative numbers, so there's the least sign changes. It doesn't matter. I'm just going to go with the first one because it's already labeled x1, y1. So that's going to be y minus -9, which is +9, equals -1/3 times x minus 6. And so that's going to give me y plus 9 equals -1/3 x, and then I'm going to divide -6 by -3, or multiply it by -1/3. Either way, same thing. That'll give me +2. And then from there, I'm going to say that's going to give me what? I'm going to give all my constants to the right-hand side, so I'm going to say y equals -1/3 x, and then I'm going to subtract 9 from both sides. So it gives me -7. So now this is in slope-intercept form. Slope-intercept form. And then now I want to put it in standard form, so I want the x on the other side. So I'm going to say this is going to be 1/3 x plus y minus 7. Now, you may see this where, you may get it wrong for other reasons. It should take this answer, but the answer they may show you, let's say you make that -7, you made it a positive or something. you may see it written also as the following, where they multiplied everything by 3. You don't have to do this part, but usually they like the leading coefficient, or all the coefficients to be not a fraction if it can help it. So they'll multiply everything by 3, and they'll say this is x plus 3y equals negative 21. Remember, multiple lines, this is the same line, they're just multiples of each other. And so you may see this as written as the answer. It should take this, because it's in standard form. But for some reason, if you get it wrong and they show you this, and you're like, wait, I got fractions for my slope. The slope's still the same. It's just they use all integer coefficients. Sometimes they'll make sure that x is positive as well. You'll see that. One other thing I wanted to show you, though, when we're talking about sometimes when you're passing through 2 points, if you had another exercise, and I can't remember if it shows up in this lesson or the next, but what happens is if you have another exercise, you could have something like 6 minus, let's say, just 7 as a point. Let's say this is the same exercise. So write the equation in standard form of the line passing through the points. And they'll give you like 6, negative 7, and let's say something like 6, I don't know, 4. And right here, if you notice something, if you notice that you have the exact same value and the exact same coordinate, both x's are equal to 6, well, the only place I'm going to have that happen is if it had a line where all my values are 6. Because if it's a straight line, right, all lines are straight. But if at 6 here, if 2 of my points, right here at 4, and right here at negative 7, well, 2 of my points are on the same, they have the same x value. All my points have the same x value. So this is the equation of the line right here. It's just vertical. All right? So you don't need to go through the whole process plugging in, because if you try to find the slope of this, you're going to find out that m equals undefined, and then you're going to be like, wait, I'm dividing by 0. Some students get that confused with 0. Another problem very similar to this is if, for example, if you had, let's say it's same thing, only you have something like 3, maybe negative 7, comma, and 4, negative 7. This is the same thing where all my y coordinates will be negative 7 because I have the same y coordinate in both points. And if that's a line, then that meant all my y coordinates had to be negative 7. And so that's the equation line. You don't have to go through. Here, this actually works because a horizontal line you can actually use point slope form on. You'll get 0 back out for your slope for this example. And so you can actually work that out. But it simplifies, and students think they've done something wrong because terms cancel out because there's 0. But just remember, if it says find the equation of a line given 2 points, and the exact same coordinates has the exact same value, like my x coordinates have the exact same value, or my y coordinates have the exact same value, you're looking at a vertical line if it's x equal a number, and a horizontal line if y equals the same number in both coordinates. Just something to watch out for. Make life easier. Makes doing your homework a bit faster than having to go through finding the slope, using point slope form. It's just you can do it by examination. And that's it for today. Y'all have a great one.